Hello, everyone, and thank you for joining us for today's webinar, What's New in Femap 2020.1. My name is Jonathan Hill. I'm an engineer here at ATA's Northern Virginia office, and I'll be with you for the duration of today's presentation, so I'm excited you're all here. I do have just a couple quick notes first, starting off with that we are recording today's presentation, and it'll be available both on our software website and on our YouTube page, either this afternoon or tomorrow. So keep an eye out for that if you want to rewatch anything or share it with a colleague or anything like that. In addition, you'll notice that everyone's been muted for now. That's just so that we don't have any interruptions or anything during the presentation. But there will be time for question and answers at the end of the presentation. So I invite you to stick around for that. I'll unmute you so you can ask questions at that time, or you can ask questions during the chat. And actually, you can ask chat questions at any time throughout the presentation. Just note that I'll probably wait until the very end to come back to those questions as well. I'd also like to give just a quick intro to ATA before we get started. So ATA is known as being a high-value engineering services company where we have expertise in design, analysis, and test. And we're really excited to help our customers overcome product design challenges across a wide range of industries, just some of which are shown here. In addition to that, we're able to leverage that experience through our role as a value-added reseller for Siemens Digital Industry Software, which is the new name for Siemens PLM Software. In that capacity, we offer training, free resources, and hotline support for a variety of Siemens products. Those products include Femap, which we'll be discussing more today, as well as Simcenter Nastran, as well as others like Simcenter 3D, NX, and Star CCM+. We host a technical support hotline that's available by phone or through our software website, and that runs from the beginning of the day on the East Coast until the end of the day on the West Coast, and is staffed by engineers who are using these tools every day. And then I also always like to point out that we develop the official Simcenter Nastran training materials and are the preferred provider of Simcenter Nastran training in North America. Finally, I always like to put in a plug for our software website. So this is a great spot to come to if you're looking for product information or if you want to see our upcoming schedule of training classes and other webinars. Probably my favorite part is the free resources section. So we have white papers and APIs and presentations and on-demand webinars and so much great content that's all available for free. So I'd invite you to check this out after the presentation, and also let us know if you have any ideas for other content that you'd like us to work on. Just reach out to me. We'd love to hear that. With that, though, we'll go ahead and jump into today's presentation, What's New in Femap 2020.1. Again, my name is Jonathan Hill, and I'm excited you're all here today. So I'll start off just with a quick run through of what we'll be discussing. We'll start off just with an introduction and some basic notes on this release, and then we'll jump into more specific updates. And we'll be switching back and forth between PowerPoint and some live demos in Femap. So we'll step through visualization and user interface enhancements, geometry editing, pre-processing, post-processing, and solver support. And then finally, at the end, we'll have time for questions and answers. So first things first, Femap 2020.1 is available now. And actually, 2020.1 Maintenance Patch 1 is available now. So that's available for download through GTAC. Now, maintenance patches are available as full installations. So if you haven't updated to this version of Femap yet, you can just go ahead and install that first maintenance patch. But they're also available as smaller patches. So you can also download just a small executable that will update your existing 2020.1 installation if you already have that. In addition, we'll discuss on the next page which version of Nastran 2020.1 ships with. But if or as Nastran updates are available, you can expect to see those on the GTAC website as well. So I've included the link where you can actually download the software. You can come back to these slides after the presentation to grab this link. And then just remember that when we jump to a new feature release like this, you'll also need to update your license file. And I have the link here as well, where you can go to GTAC and pull your new license file or dongle codes. Overall, this release is going to continue along the path that Femap has been on for the last few years, mostly focusing on building upon their strong capabilities that allow us to maximize our efficiency of finite element analysis tasks. And so that includes through geometry idealization and processing for finite element models, powerful meshing, model creation, and interactive editing capabilities, in-depth support for industry standard solvers, and flexible customization tools so that we can streamline our analysis processes. This release continues the biannual release cadence that Femap started last year. So the Femap development team is going to be targeting feature releases every April and October. And these feature releases will have new features and expand functionality. And along with that, they will be accompanied by database changes, which means you can't open a 2020.1 model in Femap 2019.1. And they'll also require licensing updates. In addition, in between these feature releases, we can expect to see maintenance patches that'll be available as needed, but these will only be critical bug updates, so the maintenance patches won't have database or UI or licensing changes. Like I mentioned on the previous slide, maintenance patches will be available as full installations or as patches to your existing installation. Now, just to keep track of specific numbering schemes, Simcenter Femap 2020.1, which was released in November, supersedes Femap 2019.1, which was released last May. We can expect this fall to see Simcenter Femap 2020.2, or later this spring, I mean. In addition, Simcenter Femap 2020.1 is going to ship with Simcenter Nastran 2019.2, so both of those came out last fall. And I would expect sometime this winter or in the spring that they'll release an update so that you can update Femap 2020.1 for Nastran 2020.1 as well. So with that, let's jump into our visualization and user interface updates. And the biggest change you'll see here is that all of the icons, over 1,600, have been redrawn. I think it looks pretty slick myself. And overall, they've been designed to maximize familiarity. So you'll notice that the icons are almost the exact same, but in some cases, they have enhanced color contrast and they've been changed just a little bit to provide a more consistent theme. Now, the motivation behind this is to allow future editions of Femap to fully support high resolution displays. So currently, and in past versions of Femap, scaling is either disabled, in which case Femap is drawn at 100% resolution, and on some new high resolution displays, that can lead to text and icons being very small and hard to read, or scaling is handled by Windows, and since Femap is currently scaled via extrapolation, that would lead to blurry text and icons. So the motivation for changing to these new vector images and icons will be that scaling will always look great. It'll always be in the high resolution that we expect. But just keep an eye out for those new icons. Continuing on with our visualization and user interface updates, there's now the capability to view CBUSH element coordinate systems whenever element coordinate systems are displayed. So this wasn't previously available. There wasn't a very easy way to check what coordinate system a spring was using. And this is really important, especially if we're going to be using those spring elements to pull forces for bolted joint analysis or anything like that. So this is just a great way to check what orientation those springs are using. Now it's available for both coincident and non-coincident spring elements, and the size is going to be controlled with the symbol size. Next up, the color palette button has been updated to actually show the current color, as well as any non-default pattern and line styles. So over on the right-hand side, I have just an image of if I was editing a property. Previously, we had color, and we can type in our numeric code for that color. But before, we just had a button that had the word palette inside, which you could click on that and select your color, but you didn't really know until you clicked on the palette button what the actual color was set to. So they've updated it now so that instead of just saying palette, now you see the color here. If you have any different patterns or line styles, that'll also show up in that dialog box. So just kind of one less step that you need to actually check and see what the current settings are. And then finally on this slide, there's a new icon for select from standard selection dialog. Now it's going to be available anytime we're choosing from checkbox entities. And that just lets us open up our standard select dialog. So if we want to paste in a number range or use pick or anything like that, this is just another way to select those instead of having to click through one at a time or highlighting in big chunks. And then finally, to close out our visualization and user interface updates, they've made a lot of changes so that any number that's displayed in the graphics window, users now have complete control over how that number is displayed. And by that, I mean controlling exponents, how many significant digits there are, things like that. So there are different ways to set this. The first is through global options, and that's available under File Preferences, and then on the Graphics pane. And so I have that here. You'll see down at the bottom, they've added in a digit control section. And so there are two buttons here. The first, locale, will open up a section that lets you choose what the decimal separator looks like, if you have commas between hundreds and thousands, what your exponent character is, if you want negative signs changed differently. So that's kind of the number style. And for all of these, there will be an example at the top to let you see what those settings will actually result in. And then in addition, on the digit control, there's a global options button. And when you open that, this is where you can choose between kind of the default numbering scheme or exponent or significant digits. You can set the number that is automatically rounded down to 0. So if you don't want to see these really small values, you can increase this and then it'll just round those down to 0. In addition to setting these global preferences, you can also control these individually. So you can have load vectors with one digit setup and your legends with another and so on. So you really have complete control to get these numbers looking exactly like you want. Should be really great for reports and stuff so that we can just have complete control over what our results look like. So with that, I'm gonna hop over and poke around in Femap a little bit just so that we can see what some of this looks like. So I have just a simple truss model here with some loads and things on it. And the first thing you'll notice is just that the icons have changed a little bit overall. I think they're very similar to before. I haven't gotten stuck wondering where an icon moved to or anything. So I don't think that should trip anyone up, but just note that they have changed a little bit. The first thing I wanted to just point out is, like I had mentioned, our new color palette button. So before it used to just say palette here, but now I can see this blue color. And then if I click there, then this is where I could come in and I could start to change what my different patterns are if I wanted a different line style. And then that'll update and will be reflected in my model. So again, pretty intuitive, but I think it's a nice change. So if I change my transparency or anything, then that'll go ahead and update in the model. In addition, I can hide my beam elements now, and I have some springs here. And so I had mentioned that there is now the capability to view our coordinate systems for our spring elements. And so in this case, we'll see that, for instance, this top one is using a different coordinate system. It's important that if I'm pulling my forces from these springs, I want to know which directions that correspond to. So of course, in this case, I might want to come in and actually just change the orientation of that spring to match the others. And then finally, if I start to turn everything back on, we can take a closer look at some of our digit control options. So again, we have global options that are available under File Preferences on the Graphics tab. So I can come into the locale button, and this is where I can start to change what my decimal separator is. I can change if I want commas or anything between large numbers, what my exponent character is, if I want negative values to be in parentheses. And these will all update on the example section at the top. In addition, I can come down to options, and then this is where I can start to choose between the default or exponent or significant figures. And then for these, you can choose how many digits you have. You can choose if you're forcing them all to have exponents or not. This is where you can set your global round to 0 value. So for instance, if I change this to a much larger number, then we'll see in the preview that this is now just going to be 0. So these are our global options. But in addition, either through F6 or through something like our like the post-processing toolbox, we'll see that there's a new digit option in here as well. So if I click this now, this is going to be controlling just the legend digits. And so in this case, for instance, I could come and I could say that I want to use exponents. I could even preview in the graphics window. And so I can make changes that way as well. With that, let's hop back over to PowerPoint now. And we'll continue on with some of our geometry editing updates. And there's some pretty cool stuff happening with the meshing toolbox in Femap 2020.1. This is actually the initial release of Smart Select for feature editing, which leverages Siemens Synchronous Technology for translating and rotating surfaces. You might be familiar with this synchronous technology. It's available in NX and Solid Edge, but essentially it allows you to automatically select additional surfaces that are offset, identical, concentric, collinear, and or have tangent edges, and it'll move those all at once. So it makes it really easy to move a feature back and forth. So I have a couple examples here in PowerPoint. We're going to be selecting the yellow faces. And so with this new offset detection that comes with the Smart Select, I can select just the single face, and it'll be able to move that entire rib. So it automatically knew to grab the face on the other side, as well as the fillets and the blends and everything. Previously, we didn't have the offset detection, so if we clicked over here without that, it would just make that edge thicker. So again, it's pretty cool to be able to move entire features if you need to do any of that geometry editing directly inside Femap. It'll also work with rotate commands. So in this case, if I select just a single surface here, it'll go ahead and rotate right along our model. There's some new translation options available as well. So previously, if we were going to be translating a face, we only had the default translation option, which is where you would select a vector and optionally a distance, and then you would select the faces that you wanted to move. There are some new options. One is auto normal, where you just pick a distance, and then any surface you click on, it'll just start translating out normal to that surface. And then there's also interactive, in which case you select a surface, and then interactively it will pop up a box asking you for the vector. Still in the meshing toolbox, blend removal is overall just a lot more robust. So it'll still attempt the previous all at one time method, but if that fails, it will start going through removing blend chains one at a time, and it'll even go back and make a second pass as needed. So they've noted that this might be a little bit slower than it was before, but it should be a lot more robust in terms of removing those fillets. So with a model like this, we'll see that it is able to come and get rid of all those fillets, and it'll even get rid of stepped blends, which it might have struggled with before. So blend removal is a lot more robust. And then finally, if we're creating washers in the meshing toolbox, there are some new alignment options that are available. These were available previously for pads, but not for washers. And so we have a couple choices here. The default automatic is what was available before. And in this case, it looks like it's just aligned to the global X direction. We can also specify a vector that we want to align those washers to. But then I think the coolest ones here are going to be tangent to curve and perpendicular to curve, which do exactly what they would expect. But it's just great to have additional options so that we can get that mesh exactly the way that we want. Now we can hop back into Femap and see some of this in action as well. So I have just a simple model here that I threw together the other day. So we can come in the meshing toolbox and start to look at how some of those feature editing commands work. We'll see here that we have Smart Select, and if I have that off now, this is going to be the same functionality that we had before. So as I start to click on a surface, it'll just make this, it'll just start to make these faces thicker. I gotta put a distance in first, that'll probably help. But then just like that, then we can just kind of come in and make them thicker. But if I have Smart Select on, now it'll go ahead and it'll start moving the entire feature at once. So this is really helpful if we want to move that entire thing without making it thicker. It'll also work on some of our features like these ribs. And it actually knows that this rib is the exact same as the rib on the other side. So it'll move both of those as I start to do that. I can also rotate. So if instead of just translating, if I want to rotate, similarly, it will be able to tell that there are other ribs that are the exact same. And so it'll rotate all of that together. So we can come in here and we'll see that it'll just start to rotate those around the model as well. So I really like those new features. In addition, I mentioned that blend removal has been improved. I think it probably would have worked on this model before, but we'll see without any problems, it's able to go in and remove all those blends pretty quickly. So just to see that again. And then we can also play with our new washer settings. So again, that's going to be in geometry editing. And then in washer, now I have these alignment options. So the automatic, I think, is just going to be aligned with the global x-axis. But I can change automatic to either tangent or perpendicular to curve. I think that'll be probably my favorite use of this. And then I can go in and either do tangent or perpendicular. So again, some pretty cool new options here that weren't available in previous versions for geometry editing, just to make that a little more intuitive and a little more smooth. So we'll continue on with some of our pre-processing updates, and we'll start off with some meshing enhancements. The first is going to be some improvements to our edge or skin element commands. And overall, this workflow is just going to be streamlined compared to what was available previously. So for instance, if you have this green shell mesh and you want to just outline all of the free edges with 1D elements, now you just come and pick your edge skin elements command, and then you'll either be choosing faces or edges to skin. This makes it really easy to pick either tangent or continuous faces and edges. There's also a new model free face and model free edge that'll just grab all the free faces and all the free edges. But so the new streamlined workflow is that you'll pick your edges or faces first, then you'll pick your property, and then it'll go ahead and create those new elements for you. If you're creating line elements, there will also be an option or a prompt to apply the appropriate line element offsets at the same time. Continuing on, there are some new options inside the mesh solid command to control how nodes are merged during that solid meshing operations. So this is going to be for solid tetrahedral meshes. And in the example over here, we have just a rectangular block with 4 sections. The first 2 sections have already been meshed, and so I have some examples showing what it looks like as the rest is meshed. Now, 0, 1, and 3 were previously available. Number 2 here, into model, is going to be our new option. So if we have merge nodes set to off, when we mesh this, no nodes will be merged. So we have coincident nodes at all of the interfaces between these different sections that were meshed. If we have merge nodes set to new nodes, it will merge nodes within the section that was just meshed. But this new section that was meshed is not attached to the original section that was meshed. If we have number 2 into model, it'll still merge the nodes inside the new section, but it'll also merge that new section onto the original mesh where there are coincident nodes. But note that for this number 2 into model, the coincident nodes that were already in the model weren't merged together. And then our final option, number 3, all nodes, kind of goes through the model, and anywhere it finds coincident nodes, it'll go ahead and merge those nodes. So you need to be really careful. I think number 2 is really cool. That's the new feature here. So that's a great way to go ahead and connect everything without having to separately go back and merge nodes after you create them. In addition, there are some updates for rigid connections and swept meshes. So for the mesh connect rigid command, you can now specify minimum and maximum target nodes per source node. And in addition to that, you can choose if target nodes can be mapped to multiple source nodes. So we have an example here on the right, the red, these are RBE3s in this case. So you can see originally, each element is attached to 3 or 4 target nodes. But now with these new options, we can say that you want each one attached to at least 5, for instance, and you can have target nodes end up in multiple source elements. In addition, performance is going to be enhanced. So in some cases, it'll be 30 times faster than before. In addition, there are some more options for the mesh sweep command, specifically when you're sweeping along a mesh. So in this case, I have kind of the same thing shown here 3 different times. You'll see that the blue elements are biased towards the top and the green is biased towards the bottom. And there are just different options for if it's going to merge the nodes while it sweeps, as well as if it will follow only the visible meshes or all visible mesh. So we'll take a closer look at this in Femap in just a second. I do have one more set of sort of meshing updates to share before we hop back to Femap. And the first is that there's a new check that's available, and that is a check for mesh interference. So this will search through your model. It will include cross sections of 1D elements, as well as thicknesses and offsets for 2D elements. And the results are that interfering elements will be highlighted, and you can optionally create a group so that you can review these later. I'll note that it won't catch elements, or it won't flag elements that are attached to each other. So for instance, if you have a box of shell elements and those the sides are connected together so that you don't have any free edges or anything, when you run the mesh interference command, even though you have some overlap in the corners from the shell thickness, it won't flag that in the mesh interference command. But if you have that same box and the sides aren't attached, when you run the command, it'll know, for instance, in the corners that those meshes aren't attached and that the thicknesses are passing through each other. So it'll go ahead and flag that for you. There's also some force enhancements. So previously, you could only sum forces for a single load set at a time. But there's some new capability now that allows you to list individual load summations for multiple load sets to the message window simultaneously. And I think the cooler part here is that there's a new checkbox to send those summations to the data table. So you see here in our example, we have two different load sets that were both summed and then sent to the data table. And this is just a really convenient way to get those load summations into columns if you want to include that in a report or start summing them across load sets or anything like that. With that, let's hop back to Femap now, and we'll take a look at some of those swept mesh options. So this is the same model that I had in the PowerPoint. Again, these are just examples of this original section. So we'll see that the blue shells, these are shell elements. The blue is biased towards the top, the green is biased towards the bottom. So although they have the same number of elements on each side, the element edges and the nodes don't line up as you go across. And so what happens is if we, so the new thing here is that we have some new sweep commands. So when we come in to kind of sweep these pink elements across, and we're going along element edges, so I don't have any geometry here. I can choose whether or not I want to merge the nodes, so that's new and is pretty cool in this version. But I can also choose if I want to limit the sweep to the visible mesh. So just for now, I'm going to hide the blue property. So we only have our green property now, and I'm just going to take a couple looks at what this sweep mesh will look like. And so in the first case, we're going to uncheck the limit sweep to visible mesh. And so even though those blue elements are hidden, it knows that they're there and it knows that it's connected on the other side. So it will go ahead and adjust the solids that were swept out so that it's still attached to all nodes on both sides. And if I did a coincident node check of these, because I hadn't merged nodes turned on, it went ahead and connected so that the pink solids are attached to our shells here. Now, if I do the same command, but I uncheck that now, what we'll see is that now it's going to ignore those blue elements. So even though it knows that they're there, it won't pay attention to them. And so we just get a regular swept mesh that is only aligned to the green. So it's just our regular, kind of what you would expect from a swept mesh that now won't line up with these blue shells. The other thing I can show in this model, I threw in just a little beam over here just for an example. So again, we have pink solids as well as our blue and green shell elements. So I'm going to turn on our thicknesses. And so I'm just going to show how the mesh interference check works. So I'm just going to select all the elements in here. And now it's going to highlight the elements that it found in interference. Now for both the first and third section, because I didn't have the solid mesh merged with the blue elements, it knows that there's some overlap between the thickness of the shells and our solid elements. So it flags that, which is pretty cool, helps me know that these aren't attached. You'll notice here where all the nodes are merged, it didn't flag even though there's the same overlap between our shells and our solid. And then coming back over to where our beam was, it knows the cross-section of that beam. So even though the actual 1D element itself doesn't pass through any of the other elements, it knows that the cross-section does. And so it'll go ahead and flag those as well. So we'll wrap up our pre-processing section with some updates to loads and things like that. The first new feature here to point out is that it's now possible to create multiple new load sets based on multiple output sets automatically. So previously, you could only create one new load at a time based on one output. And a use case where you might want to do something like this, say you have a transient thermal analysis and you want to create temperature loads based on each of those output time increments. Now you can go ahead and create all of those at once. There's also an option if you're, for instance, doing something where you're creating load sets based on displacements so that you can have enforced displacement constraints. There is a new option to automatically create corresponding constraint sets based on those displacement load sets. And there's also additional options for improved phase selection during pressure loads. Now, the second main bullet here, I think, is probably the hidden gem of this section. There's a new ability that lets you copy load and constraint definitions to multiple sets at once with a right mouse button. So I'm going to jump back to Femap in just a second to show that, because I think it's pretty cool. And then the final bullet here is that there's some additional control here over listing layers to the message window and whether the entities are included and things like that. So I do want to hop back to Femap now and just take a look at that copy load option that's available. So we'll see in this model, I just have a single load set with a single load definition. But I think we've all had situations where maybe we have just a ton of load sets in our model. And right now, there's not a great way if I want, or previously, there wasn't a great way if I wanted this load definition to be inside all of my load sets. There wasn't a great way to do that. Now I can just right-click, copy to set, and then I could come through and just select all of those at once. And then when I hit OK, it'll go through, and now this load set is everywhere. So really helpful for copying loads. The same feature is available for constraints. So again, something else that I'm just pretty excited to have now. And we'll continue on moving into post-processing. And I think this is probably one of the biggest impacts on Femap users. And that is that some element output now uses new output vector IDs. So the chart here is from the Femap help. The center column is the output vector IDs from previous versions of Femap. And then on the right is the output vector ID from 2020.1 and also going forward. And you'll see that in some cases, the numbers have been adjusted so that there's more space between them. And that's really the motivation, is that the Femap developers wanted to give themselves room to support new types of output for new types and different types of elements. So they just felt like they were starting to run out of room. And so hopefully doing this one change now means that they won't have to change output vector IDs anytime in the future. Now, if you have a Femap model from pre-2020.1 that you open in 2020.1, those output vector IDs will be automatically converted to the new IDs during the neutral file conversion. But I think you're probably all realizing that there are additional impacts to APIs that might be out there that work with output. So I have a few notes here as well. The first is that existing scripts will continue to run using pre-2020.1 IDs, but they should be updated. So if you have a Femap API and it's using hard-coded output vector IDs for, a specific, like maybe top plate von Mises stress or anything like that, when you run that API in Femap 2020.1, it will convert those hard-coded output vector IDs to the new output vector IDs. But you should still be careful, because you just want to make sure that it's using the specific output vectors that you think it will. It's sort of doing all that in the background. So again, you just want to be careful with that and should update APIs when you have a chance. It will throw a warning message that just to let you know that the output vector IDs have changed and reminding you to update. So just be aware that when you run your existing scripts, they should work okay, but you will get that message. And there's a few other changes as well. So the output object has been fully depreciated, and new APIs will use the results browsing object And then in addition, there's actually an entire new set of V2 API methods and properties that'll be added. So that's how Femap knows whether your API is using the original commands or the new ones, is that we'll be using these new V2 versions. And then there's a few new API calls as well. There's one that allows you to convert your IDs between 2020.1 and the previous numbering scheme. And then there's also, and this bottom bullet I think is pretty cool too, there's a new API that can specify output based on a predefined quantity. So for instance, instead of knowing the output vector ID for top von Mises stress and hard coding that in and hoping that it doesn't change in the future, you could actually just write your code to search for top von Mises stress, and it will be able to go through and pull whatever the current output vector ID for that quantity is. The other change that I wanted to talk to for post-processing is some changes to isosurface plots. Now previously you could select a specific value to plot the isosurface for, but now in 2020.1 you can have that be either a positive or negative cap so that you see all values that are above or below that value, which could be especially useful for something like topology optimization if you wanted to plot your mass fractions or something and only see what was greater than 50% or something. It'd be really easy to see that. We can take a look at that in action too. So if I just come in and I plot my von Mises stress on this part, it's constrained at the holes, and then I have a load on the slot here. If I come over to the post-processing toolbox, I can change to isosurface. And so originally we didn't have a cap, and so it was just a single surface that you can move back and forth. But now you can do cool stuff like negative caps, and then interactively change this with the little slide bar down here at the bottom. So I appreciate you guys sticking with me. We'll wrap up now with some updates to solver support, and we'll start with Simcenter Nastran, where Femap now has the ability to handle large IDs. In addition, there's more creation and read-write support of monitor points, DMIG entities, and this bolt force card being written outside of solution 401 and 402. I'll make another note that the DMIG entities are available either as internal Femap matrix input entities or as external punch files. And then for solutions 401 and 402, there's some new nonlinear control options. So you can now restart from the end of subcases or at the last converge time step. For solution 401, there's now the option to disable specific categories of mechanical loads. And for solution 402, you can specify which version you want to use default parameters from. And again, solution 401 and 402 are the fairly new multi-step nonlinear simulations that are available. And then to cover ANSYS Abacus and LS-DYNA, the ANSYS translator has been improved and support has been added for multiple excitations during random analysis. The ANSYS translator also supports variable shell thickness now, and element and node selections are more completely supported when those input files are read in. Those selections will become Femap groups. And then finally, with the ANSYS translator, you can now write just a portion of the model, and that'll be handled the exact same way it is when writing to Simcenter Nastran, where you essentially have a group that has everything in your model that you want for a specific analysis, and you write just that. For LS-DYNA, LS-DYNA also has translator support added for variable shell thickness and for writing a portion of the model. And it also adds a new beam formulation method that's available. And then finally for Abacus, there is no longer support for fixed field format files, which was incompatible with the Abacus solver. There's also added import of connector section types bushing and beam elements. And then finally, there's better import and export of entity titles and names, and import and export support for deloads. So that's going to wrap up everything that I had prepared for you guys today. I've changed the settings now so that you can unmute yourself in the Zoom application if you'd like to ask questions by phone. So you can do that whether you're in the web interface or in the Zoom application. Just note that if you're in the Zoom application, the unmute button might actually be back on the main meeting tab and not in the screen share window. And you can also ask questions through the chat at this time as well. So there's a question in the chat. Thank you for submitting that. It asks, are there any major issues with maintenance patch 1? And are the maintenance patch 1, does it require admin rights to install that? I remember reviewing the README for maintenance patch 1. So that's available when you download that patch. I don't remember specifically what maintenance patch 1 was targeting. I imagine it was just small bug fixes. But I could go back and check that for you. I would anticipate that it probably requires admin rights, but I'm not sure on that either. So I'll check in on that and get back to you. But thank you for the question. There is another question asking, is there a plan to be able to add tangent and perpendicular to curve when doing washers in the meshing toolbox? I think that's what I showed. So I can go back and show that again if you'd like. Oh, simultaneously. So the question is, can you do tangent and perpendicular to curve at the same time? I'm not sure if there's a plan. I could reach out to the Femap developers and ask. If we come back to our model, so essentially asking, like, I have perpendicular right now. The question is, could we also do tangent to curve? You might have to go back. If I selected the interior curve. Oh, so it already knows that there's, so it won't even let me select that curve. So that isn't something that you can do right now. I'm not sure if they're going to add that in the future, but I can reach out and check. So great questions, guys. Thank you. Are there any other questions? Again, you can unmute yourself in the chat or by phone, or you can submit questions in the chat. I'd also like to encourage everyone to keep an eye out for the recording. That'll probably be available either this afternoon or tomorrow morning. And also check out our software website. Let me know if you have any requests for future webinar topics or future resources that you'd like to see. But unless there are any other questions, I think we can probably go ahead and wrap things up pretty soon. The final question, I think, we will send an email with the recording link when it's available. So I'll let you know when that happens. But otherwise, if there are no additional questions, I appreciate everyone taking time out of your day to come along for the presentation today. So thanks, everyone, and have a great afternoon.